name is Justin Pachter, and today, along with Greg Johannesson, we're going to be talking to you about programmable logic controllers. From here on out, we're going to be referring to them as PLCs. PLCs are the backbone behind today's industrial automation. And a PLC is basically a computer that includes both hardware and software, and with that, it controls production equipment and/or processes. Let's first take a look at the history of the PLC. Before PLCs, hardwire relays were used for automated processes. Relays are fully mechanical, and they had to be set up in very specific ways for the automated process to act as desired. And because they were mechanical only, changes to the logic were extremely costly, and they also were pretty unreliable. You still might find yourself saying, what is a PLC exactly? A PLC is a digital computer that uses both hardware and software. The key element here is the software. PLCs contain programmable logic, hence the name Programmable Logic Controller, and a programmer can code the logic on his computer and download it to the non-volatile memory on the PLC. Non-volatile means that the memory can retain its content without any power. You can see in this graphic that PLCs accept inputs and evaluates these inputs based on the logic that is downloaded into the memory, and it changes the state of outputs to control a machine or process. And a really important thing is that the PLC does this in real time, which is a very important aspect. Another huge advantage of a PLC is that it can withstand extreme conditions inside maybe a hot factory or placed somewhere where there might be extreme vibrations. I really want to drive home the fact that programmable logic controllers are seen everywhere in everyday life without us even knowing. PLCs control things like roller coasters, and even things such as a traditional oven in your kitchen. We truly wouldn't be able to have all the technology we have available to us today without PLCs. Now my friend Greg is going to explain in more detail exactly how PLCs work and show you them in action.
Hello there, I'm Greg Johannesson. We know that PLCs replaced large relay control panels as a means to operate automated systems. PLCs are programmed using ladder logic, sometimes referred to as relay ladder logic. It's called ladder logic because the schematics closely resemble a ladder with horizontal rungs, as you'll see in the following examples. First, observe the simple relay drawing. The relay is powered by the flip of the blue switch. This energizes the relay's coil and closes the red contacts, providing power to the lights. Opening the blue switch de-energizes the system. It's a simple control circuit. Now, let's take a look at a control circuit utilizing simple ladder logic. In the drawing, the dashed lines are inputs and the circles are outputs. When inputs on the left provide a clear path to the outputs on the right, the circuit is said to be true or complete. Notice the run output on the first rung becomes an input in the second and third rungs of the diagram. The off and limit inputs are always valid until removed by a limit switch or an off button. Ladder logic is normally read left to right and top to bottom. On the first rung, when the on input is provided, the run output is achieved. The run output feeds rungs 2 and 3 as an input, and the actuator will continue to operate. At this point, the system is self-sustaining until the stop or limit inputs are removed. At that point, the actuator will no longer operate until the on input is given again.
So, one of the most common applications of ladder logic is at your local car wash. So let's take a ride down to the car wash and see how things work. In order for a programmed process to begin, all of the conditions must be met. In other words, all of the inputs must be present to make the circuit complete or true. So, here we are at an automated car wash. Did you know that when you go to an automated car wash, you're providing inputs to a programmable logic controller? That's right. The car wash is going to run through an entire sequence of events. Before it can do that, you, the user, have to provide it some inputs. Depending on how much money you put into this machine here, and depending on what program you select, you're going to be telling the programmable logic controller what sequence of events it is going to run. Whether it be an an express wash, a super wash, a deluxe wash, or the works. As the car enters the car wash, the car is actually going to provide some input to the car wash, so the car wash knows when to begin its sequence of events. If you look down here on the ground, you'll see a switching device, which when the tire runs over that switching device, it begins the underbelly spray of the car wash sequence. That's one of the first inputs that is provided. The second input provided to the PLC is this tire switch here. Once this tire switch is activated, all the required inputs are provided to the programmable logic controller, and the car wash can begin its washing sequence. Thanks to programmable logic controllers and some ladder logic, I now have a nice clean minivan.
So what's the future for PLCs? One might assume that a technology that's been around since the late 60s must be near obsolete. On the contrary, as global manufacturing markets rebound from recent struggles, the market for PLCs is expected to have strong growth. With advances in PLC technology such as reduced costs, size, and power requirements, chips utilizing programmable logic have even become a viable option in products such as smartphones and HD TVs. For now, the future is bright for PLCs. Thank you for watching our video. We hope you enjoyed it.